Hi. Now internet works, so I can have my session. I'm Roberto, I'm from Italy. I work with Azure for some years. And today I want to show you the deep capabilities of Azure App Service, which is, in my opinion, one of the most one of the most relevant platform as a service now in the cloud market. How many of you are using Azure or App Service or both? Okay, great. On .NET, other languages, who with other languages? No? No? Okay. Shame on you, no? Okay, perfect. So, we have just 5 minutes less, but no problem. I can go ahead with a brief introduction. So, the brief introduction is how to get your web application be scalable in terms of architecture. Okay, as we as developers usually think about the code, think about the architecture of the code, but not really the architecture of the actual infrastructure that will run our system. Okay, so I viewed a lot of deployments which were actually poor because of a single worker that does everything, okay? So in that kind of situation, you can have a person, a deployer, even an automated engine, something like that, that deploys the code to that worker. Okay, but when you add another worker to scale out, so to balance the traffic, to have more power under the hood, this change, of course. So you need probably to put in place some sort of load balancer in front of the workers. And when you put a load balancer, an issue raises. So you probably have the same user going to one server and to the other server at each request. So a problem arises, and the problem is the state. So where do you save the state? The state is what you have in the local memory of the application, what you have on the local disk. It's the local state of the machine executing your code. So back in the times, we used the session in ASP.NET Web Forms, for example. That session ran into the local machine, except you externalized to a SQL Server, Redis cache, and so on. This kind of externalization makes your worker stateless. So the way is that one. You need to make your worker stateless and externalize the state to another state machine, like a file server, for example, like a SQL Server, like something else, okay, where the state resides. And then, in that situation, the deployer should deploy to the state server, and the worker are just poor, stupid worker with some pointers, some configuration, but actual no code, nothing inside them. Okay, this is the arrival point that we need to implement when we want a scalable infrastructure, okay? This is also App Service, what App Service does, okay? So, let's make a brief introduction to the topology stuff of App Service. In App Service, the main artifact is the plan. Okay, a plan defines the topology of the machine pool that runs your workload. So, a topology, I mean the instance size. So, I think I would like to say that is serverless. Okay, that is a platform as a service. But for pricing reason, you see that like a unit. That is, ACU is not really a CPU specification, but it's like a unit of measure of a CPU, of a compute power, and also a memory. This is why you need to be built upon this. But I want to think at App Service as a serverless infrastructure, when you just define some sort of performance target, and then the platform do everything without configuration, manual configuration of VM, provisioning, and so on. So the App Service plan is that kind of stuff that defines the size of the machine and the number of the machine. You can have multiple app service plan in your subscription. In this case, this service plan hosts all the application for this demo and also other one for the demo of tomorrow. And this is a good thing because each application is sandboxed like it runs in a container. So we can have multiple applications in the same plan, in the same machine, This is very good for resource pooling, and it's also and the isolation is guaranteed, so you can work in a slot in an application without any problem and without harm the other deployment. Of course, if you run many applications in this same app service plan, you will be probably overflow in terms of performance, so you need to use different plans. And this is what we are seeing now. Let's take, for example, this application. That is this one, just an info application that we'll find in GitHub on my account. It says hello world from this machine. But now I decided to move that single application to another service plan. That is DemosWin 2. When I say OK, the changes under the hood are just a few second change because the machines are stateless. So it's just a change in configuration. So if I press F5 right now, just hold on some seconds because probably of the warm-up of the application into another machine, the compilation, so on. But in a few seconds, I will see another machine name that means that I change the worker pool that executes this application. Also, OK, it changed. Also, I can do this with scaling. So I can go to the demos Win02 and say, OK, this application is very heavy, so I want to have 2 or 10 machines. And it's the same. Another worker is placed and is configured automatically to be load balanced between requests. So I'm expecting that one click goes to a machine and one click goes to another machine. So since this has a cookie now, but OK, this is the same one. Probably is not ready yet. Same. So let's try the last time. Another browser. OK. It means that you're thinking about it. OK, I say second, I would probably say less than a minute. OK, but the scaling is very fast, except in the demo times in conference, of course. OK. Well, next. So we saw this kind of tiers, the scaling, and now let's give a glance to the deployment option. Okay, in App Service we can have multiple applications in the same plan, and each application has its own environment, its own deployment credential. So I can download that, have a single access to an FTP folder where I can deploy the code. I also have an endpoint which is HTTPS, usable in web deploy technology. And I can also connect this with Git or continuous integration. Also, from the deployment perspective, there are some interesting things that are slots and configuration. Okay, slots is the capability to have multiple children application to a main one, to perform A/B testing, to perform staging, pre-production deployment, and then hot swap between deployments. And configuration is a great feature that encapsulates the configuration of your application on Azure instead in the code. So you can publish the code with your own configuration, even pointing to localhost with fake settings, placeholder. And the configuration in Azure take precedence on the configuration in the code. So let's see this in action. We have here, oh, well, let's try this demo because, no, something, I click saved, okay, well, no problem. Next one, I have this empty deployment. This is empty, and I want to publish my code that is available on GitHub. So the first thing to do is get the publish profile. The publish profile is just a text file, an XML with 2 endpoints. One is FTP, one is web deploy. So it has this structure. And if we give this in Visual Studio as input in the profile when we publish an application, it automatically recognizes the configuration here, and you can publish directly from Visual Studio. Okay. Also, you can connect to FTP. Okay, now it's publishing probably because of this folder, but I'm okay. Let's press an F5. Okay, it published by another method, and now I have okay this application deployed. But this hello world is just a configuration here. That name is my setting, okay? But let's think about it as a connection string. Let's think about a secret. Let's think about something that a developer should not know. Okay, but the deployment manager, yes, or the Azure manager, yes. So we can go to configuration and say, hey, override the configuration setting, my setting with hello.net Fest. Okay, let's save it. Which is the magic under the hood? The magic is that when you do this, this injects in the environment variables specific key names that are recognized by the application automatically. Okay, so if you develop in PHP, for example, it's not your case, but in case, and you use env, the environment bridge, you will see the settings too. So it's a good thing to separate the settings in the code and the settings in the actual deployment, okay? Another good thing is, as I said, the Git integration. So each application app service instance, so each site, has the capability to host itself a local Git. So I can say, hey, host a local Git inside this slot. This creates a unique Git URI that are we going to clone, and it clones it with the content are the content of the actual application I have deployed yesterday for testing. So let's see what's inside. There's just an index. Okay, let's say notepad that index. Let's update the version. Let's go also to the main page to see this complex application. And now let's git everything. With this embedded Git repository inside the application, it automatically detects the change and it automatically deploys it here in production. And also you have this version history here. And you can also disconnect it if you don't want it to, if you want, for example, to host your Git into Azure DevOps or somewhere else. Okay, but you have this kind of history that is nice. Next is the slots. So in that case, we have an application that is a great new one application, the same, but we are testing a new feature. So we created a slot that is called new feature. And that's a slot. What is a slot? A slot is a completely new, brand new application with a slightly different that is connected to another application in a hierarchical relationship. So we have in the slot the same features we have in the main application. So we can also map a custom domain if we want, but it's not the case in this demo. The case is that this new feature is like this, and I want to test this new feature for a lot of users. Okay, so before going in production, I want to test it to the 50% of the users. When I click save, at this endpoint, so the main endpoint, the parent endpoint, now is splitting the traffic between the production slot and the slot that I mentioned, the new feature. So I can perform A/B testing. So let's try again with an in private, and we see that it works Same endpoint, two different slots, balanced with the equation that I put in the configuration. Also, I can come back here and say, okay, I like it, so I can promote it in production by using the swap feature that doesn't move anything, really, actually, but just configure the actual DNS and the endpoint, the main endpoint, to point to another slot. Okay, so if I click swap, it's about a 1-2 minutes operation, and it's also telling me which are the changes that are involved into configuration, because each slot can have its own configuration. So it reminds me, hey, pay attention, this setting is not in this slot, and you're going to production, so it's very nice. Good. Then we have security. Actually, I'm talking just by a couple of minutes of security, but the main topic is pretty huge. In App Service, we can configure certificates, server certificates, so for SSL, client certificates in terms of this application require an incoming certificate to work, and we can also configure the third point that I really like, that is a declarative authentication integrated with the Azure Active Directory, Facebook, Microsoft accounts, and so on, with just configuration. That is very useful for unauthenticated application that probably runs in line of businesses. I work with companies that has line of business application with no authentication because they are inside networks with probably basic authentication with username and password, but not really an authentication and authorization per user. In that case, it would be very nice, this feature. So first thing, of course, is the certificate issue. When we want a custom certificate, we probably want a custom domain. So let's say I already configure on the DNS side this domain, asdd.cloudmakers.xyz. So it validates the property of this domain. It says, okay, I found the CNAME mapping, so I can add this. And after that, okay, I can also bind the certificate that I uploaded. Yeah, this is just a matter of refresh. Okay. And now we have the custom certificate with custom DNS name, and also this nice feature that redirects all the HTTP, the plain HTTP traffic to HTTPS. After that, we want to, and of course, this is very trivial, and it works. Okay, perfect. Okay, okay, second time is valid, perfect. Second thing is the out. This application is unauthenticated, it's just an hello world from the App Service engine. And I want to make it authenticated. So I go to authorization, I say on, I say use Active Directory, and create automatically an application to bind this identity provider to the relying party. Now, when I hit the endpoint, a front end, IIS front end that is not managed by us, is engaged with this kind of authentication. So let's take the link. And as you can see now, there's a ping back to this Azure Demos directory, Microsoft.com, which is the directory I'm using, the embedded directory of the subscription, but you can, of course, change the parameters and use your own directory. Now, the application is the same, so the application is not aware that you are authenticating to it with Azure Active Directory. It's just an authenticated application, but you can protect your resources like this, and they are integrated with your own identity provider. Okay, so governance. How many of you are involved into governance of your application, your deployments? Okay, just one. Okay, perfect. Oh, this is probably the most important thing you need to think about it as developers of this century, these years, because with DevOps, with the platform as a service, with this kind of tools, you should have control of your resources even after you develop them. Okay, it's a very important step in my opinion, because today a developer should also know the minimal amount of the knowledge that some years ago were just up to the engineers, the IT stuff. Okay, so from the governance perspective, App Service offers you all the stuff to monitor the resources, to go into the deployment, to do some stuff. For example, let's see in action this. If I have this application, and despite I'm deploying it by using Git, by using a continuous integration system, by using something, I want to back up with what is in the file system and also all this configuration. So the configuration, the settings, and so on. To do this, I have this backup that makes a zip, an archive of all the stuff, not just the file system, also the configuration, to a storage account on a scheduled basis. I just configured it to go to the backup storage. The storage is just another Azure service, a foundation service which serves a virtual machine, other services, and so on. And they say each day, make a complete backup of the stuff. The backup has this, where is it? Here. This shape, they are just zip files, okay? And also with this content. This meta is containing all the configuration of the XML to configure the application on the other side. And this is, as the name can, you can imagine, is file system, with all the file system of the application. So this is good, but not enough, because we want also to have logs, for example, of the application. Well, what I mean with logs, of course, application log, of course, infrastructure logs, server logs, all the stuff of the logs is available here. And the logs can be shipped automatically to a storage account. But often, when you need to live debug your application, it's not really useful to have that logs shipped in real time to the storage account, because you have to open the storage account, check for the logs, etc. So a nice thing is to redirect also to the local file system, but it doesn't make any sense because the local file system is stateful. So it's just for debugging and troubleshooting, because if we log into the file system and in the application we have something like that, that says, hey, go to console and use Azure App Service. Every single line of log, for example, this job that each 5 seconds logs something, will be redirected to the file system, and so we can get an entity that is attached to that log to see them in real time. So hello from the machine is coming from the code of the application, and we can go into the details without any kind of special system and overhead. Okay. Also, I can have a console. This console makes you work into the file system better, without the FTP or web deploy, and also has some tools that you can find in the official documentation to ping some resources to see if there's connectivity and so on. And it is isolated, so in this console you can do anything on the machine, on the underlying machine. You just can break your environment, your local instance, your local application, not the entire machine that are running the other workloads. This is very important. We also have the editor. The editor is like a web application hosted in your resources. So it's using your own worker machine with a view, a window on your single deployment with this editor that is Visual Studio Code web-based, that it was called Monaco. And here you can make some hotfixes. It's not it's a production tool in terms of hotfix, really hotfix, but of course it's just a hack. So you should keep in mind this and be careful about this. If you want to know the under the hood operation in terms of REST API, of automation, you can use the resources portal that is resources.azure.com that gives you all the stuff in terms of REST, in terms of JSON. So here we are pointing to that web application, and I have some action that I can perform, and also the documentation to automate this in PowerShell and so on. This is very good because if you want, for example, I have 100 of websites spare across some application service plan, and I want to automate this. And we see in the tomorrow's session how to automate that stuff with C#. And it's very useful to this kind of governance operation. So let's see. And of course, we have the standard monitoring. So indicators that are collected by the platform through metrics that you can bind to your own dashboard. In this case, I created a dashboard, a simple dashboard with 3 metrics for the app service plan and 2 metrics for the storage account to see which is the CPU percentage and the memory used and the HTTP metrics for that worker that I'm paying for. It's hanging right now, but I hope it will be refreshed in a minute. Okay. So background code, this is a great topic because every single company that I work with had a lot of background code in legacy platform like Task Scheduler, a Windows Server, cron jobs in Linux, and other stuff. How many of you are working with background code jobs and so on? Okay, half, almost everybody. In App Service, we have web jobs. So the option is to use containers to do that, and we'll see in a minute. But the good option for me to use web jobs. Web jobs are just the unit of execution inside App Service. They can be continuous. Continuous means that is a job that never finished. So for example, a job that looks from a queue for arriving, for the message arriving. In that case, that job should not finish. And if the job finishes, the engine, the web job engine, App Service, will spawn a new process again to start up again. Okay. The triggered one is just a process that can finish, that makes just one-shot jobs or a scheduled job. Each night perform this kind of optimization. In that case, the platform will run the job with a cron expression, and when it finishes, it's okay. So let's see it in action. For this demo, I use the same code for both a continuous job and a triggered job. The code is simple. I write to the console, and I wait 60 seconds. Okay. So from the deployment perspective, I can zip this build, and I can upload here. Okay, now the monitoring is working. And I can upload here in the web jobs area. I select the zip, and I say continuous or triggered. But it's not really scalable. I can use the file system because inside the file system, the web jobs are organized in a folder structure. So they are just convention-based folders that are put into the root folder, app data, jobs, and then continuous or triggered. So you can set up a pipeline in Azure DevOps or something through FTP2 that copies an output folder to that folder, and the web job is automatically configured and deployed. It's not really a lock-in API. Just take your code that can be also PHP, Python, something else, put in a folder here, and then it runs. It will be discovered by the platform, and in this case, the continuous job has a status pending restart. Why? Because my code is writing to the console, and then after 60 seconds, it stops. So the engine says, no, it's continuous, so I need to restart again. Let's see the logs. The good thing about web jobs it's that each job has its own logs, separated and isolated. In this case, we see that it's printed hello world, then it went down, and then the engine will come up the process again. In the case of trigger a web job, instead, there are just a list of execution. I configured the cron expression to where is it? Probably to run each 5 minutes. Yeah, each 5 minutes. And each execution has its own log stream that you can download, and it also has an URL that you can get via REST API. This is really powerful when you have multiple jobs to read logs in real time, because this is real time, of course. And I think is the suggested way to perform your background code in any language that are supported in App Service. Okay. Let's close some stuff because it's starting to flood. Okay. Now, under the hood of App Service, there's Kudu. Kudu is an open source project available on GitHub that contains all the deployment stuff for the engine, for Git deployments, the configuration. Then 80% of the stuff we saw is based on the actual code of this Kudu. It's like a lightweight container engine. It's not really a container engine, but you can think about it is a container engine, okay? I don't have time in a session like this to go deep into Kudu itself, but I want to give you some quick looks at two nice, interesting features. One is the Virtual File System API, one is webhooks. The Virtual File System API, let's go to this Kudu. The Kudu instance is always on name of the website .scm.azurewebsite.net. SCM stands for Site Control Manager. Here we can have this API. Now I see this result in JSON because I am authenticated. But if you want to automate, for example, the listing of the files to understand what's changed, for example, or to understand which files are deployment, to check the library version and so on, you can call this URI with basic authentication with the credential that you download in the publish profile. So with that credential and basic authentication, you can go here and then, for example, you can take all the files under the jobs, continuous, worker, and after that, you can browse this file system, and you can perform a really, really deep monitoring of your deployed application. Another nice thing is, let's come back to Kudu. The webhooks. Let's see, we have a webhook somewhere, so an URL to notify. This is just a site that provides hot webhooks. And I have this job executing, okay? In Kudu, we have two events. One is when a job finished, that we can catch and trigger a webhook. So now the code is executing. In another 50 seconds, probably will stop. And before it stops, I configure a webhooks to post the results to this URL. Now I wait here. Why it's really important is because if you have a lot of web jobs, around 100, as I manage for many clients, you should know exactly which one is failing, why it's failing, and so on. So you can create a webhook, put it, for example, to a Logic app, to Zapier. How many of you knows Zapier? It's an integration tool, but you can also use Logic apps. And in Logic app, you can also have some flows. For example, in my case, my flow is get this incoming notification that has this form. So success. If the status is different from success, so take this output URL, the log, download it with a credential, and create an email with this log attached and email me. This is very good because each morning I have 1 or 2 or nothing, and better, cases of failing jobs with the log attached, and this is so useful for debugging. Okay? Now, Linux. How many of you are using Linux to deploy your application? Okay, for performance, legacy issues, because they are already in production. Which is your scenario?
Scenario is more than .NET Core applications.
Okay.
Docker containers.
Okay, perfect. Perfect, I completely agree. For efficiency, for performance, .NET Core is great in Linux, and you can also deploy app service with Linux Worker. The main difference is Linux Worker have not this kind of features, extensive feature as I show to you, but they have just few features like custom domain and so on. But to get the gap, they support containers. So with containers, you can probably do anything you want with any language, with any configuration. So, Linux options. We are here. We should have, of course, a Linux service plan because the worker machines are different. One is Windows, one is Linux. And this is a single application. Let's see, for example, the list of application. This is, as you can see in the type, App Linux, so a standalone application with a pre-installed runtime. Those instead are container application. So if I go here, or here better, which is a complex configuration, the configuration is a Docker Compose configuration with 2 images. We want a SQL Server. That doesn't make any sense to put SQL Server inside the container, of course, but just for demonstration purposes. And the other one is ASP.NET. Also, we can create our own web application in Linux. So ASDD, Linux, container 02, Docker container with Linux. Also Windows container are supported, but it's a different stack and it's quite tricky, so I can explain it now. Now I can deploy a single container taken from Docker Hub, or even a container registry inside Azure, or even my container registry, which exposes on authentication. I add this image, just an hello world. Take this one. I take this one just because I previously cache it into the machine. Otherwise, it takes about 5 minutes to get up. In this case, it will be probably cached by the machine itself. So the startup of this container will be some seconds, 20 seconds, and so on, which is the process. A new application is created, it's configured with a container. Under the hood, the machine pulls the container from the registry and mounts it into the application. Also, we can set up, and we see in some seconds, some triggers, some webhooks, some notifications, some connection between Docker and our platform to say, hey, if there's some changes into the image application, then get automatically and deploy it. So let's see the logs. In this container logs, we will probably see the steps, download from there, mounting, extracting, pulling the layer, and so on. And after, okay, operation was concealed. This is not really predictable. I discovered that the container part takes 1 minute one time, 2 minutes another time, so start up to warm up. So I prepared another application that is the same container deployed to another DNS. But it's very powerful because you can fill the gap of Linux deployment with a container with all the configuration you want. So let's wait some seconds more. And then go to the last part, so we're almost finished. I want to leave you with some hot points that you can evaluate by yourself after the session. One is extensions. Each app service instance has the capability to host extension inside it. Well, what is an extension? Extension is something that you can also deploy by yourself. It's like a configuration for IIS and a web application that runs inside your container application, so your app service instance. When we say the Visual Studio Code editor inside the application, it was an extension, a standard extension, an embedded extension. But you can also have, for example, an extension like, okay, this hello world worked. An extension here, where are there? When I say HUD, we have a lot of integrated extension which I can choose from. Yeah, okay. I installed in this application the reverse proxy extension, which modifies the application configuration XML to enable the proxy, the reverse proxy of IIS. And it also gives me this simple web application inside the domain of the site control manager. So, for example, now I'm configuring this proxy to say, hey, if you call the website with the proxy pattern, so reverse proxy Google. And we can check this at runtime here. This is the main page, but in case we have this kind of proxy, I proxy Google. Of course, something is not working because of redirection, because I need to configure it better, it's just for the demo. But you can use this feature, for example, to make your own basic, very basic API gateway. So if you have not really a need of an API gateway now, you should take in place an API gateway, a minimal API gateway that should be also a basic reverse proxy, and you can do this by as it is. So last thing I want to show you are hybrid connection. So hybrid connection are very interesting when we have something on-premise. In this case, we have this application that has a controller, an API controller, that goes to this laptop, to MySQL on this laptop, and takes some actors and returns it by JSON. I deploy this application in Azure, and I want to use MySQL in my laptop. Okay? To do this, in this application that hosts the deployment, I go to networking, hybrid connection. I created an hybrid connection. What does it mean? That I declare the hybrid connection on Azure. I download a component in my laptop. The component is called Hybrid Connection Manager. With this component, I create a bridge, a connection to that endpoint, and this connection is used on the other side to have a public endpoint to my private local machine attached to this private internet of this hotel. So this is very good and strong because you don't need to make some complex IT configuration in terms of firewalls, in terms of net, in terms of forwarding. You can just install this hybrid component in your SQL server, for example, MySQL in my case, and then it is visible inside App Service. So in that case, when the configuration is completed, I needed to do it before the demo because it's about 5 to 10 minutes. I can see in the actors endpoint the data that is taken at runtime from my MySQL that is running here. So for example, if I go there and say, hey, I change Penelope to Penelope, a man, bad name for a man, but it's the same. Okay. Now here's Penelope, but with an F5 becomes Penelope because it's connecting in real time with my laptop here. Okay. I don't have time to talk about app service environment, but I leave you with a tip that if you have huge deployments, you can use app service environment, which in my opinion is the big version of app service. It's much expensive, but even much complete, and you can also scale to workers that are huge and heavy for heavy workloads. And I'm finished. I'm here for your question. I thank you very much for your participation here. And if you have a question, you can do this right now and also reach me out when the session closes. Thank you.
Thank you. You know, now all web jobs under application service controlled by Kudu, and we have some difficult situation. If I am stop application service, web jobs not stopped. Okay. And we, of course, we know we have two different ways for continuous and integrated web jobs for stopping. But my question is, do you know it will be changed in the future, for example, by some function, API, or button to the portal or not? Okay, yeah.
Web jobs, in my opinion, are very powerful, but they were born with some limitation that we already have. Function, in my opinion, unfortunately, are the evolution of web jobs. So web jobs are great, but in my opinion, should be containerized somewhere else, not in the app service environment. Function are, do you know the web job SDK? The software development kit, okay. Function are web job SDK as a service. So this is the direction of Microsoft. So function is that, but they also develop independently a function runtime that runs into containers. So I hope that will be the future of web jobs. So isolated components out of the scope of app service, because it's not relevant to have a web front end when you have web jobs. So now it seems like a hack that you have web jobs inside a web application. So in my personal opinion, I hope we'll have somewhere in the near future a web job that is isolated, in an isolated environment. But I don't have this information, and I can confirm to you.
Involving through the first question, the web jobs, you're talking about, are you talking about the set of the web jobs we have right now as part of the application, or are you talking about the an instance of a specific web job, what will be containerized instead of like we have right now?
Oh, I talked about that now you can, not for web jobs, but for function, you can download and run in your own container all the stack of the Azure function. So in Azure function, there are some difference compared to web jobs. In my opinion, web jobs are better because each web job is a single process, while in function, the whole function you deploy into a function app are the same process. So, for example, for deployment perspective, if you need to update a function, you are restarting all the other functions. Mm-hmm. So, in my personal opinion, my hope is that they are containerized the web job because the functions are already containerized. Okay. But until that, I have no information.
Okay, and one more question regarding the web jobs and web job SDK we got just some few months ago, SDK 3.0. Yeah. What do you prefer to use for the triggered web jobs? The console apps plus triggered web jobs or the SDK plus continuous web jobs?
Okay, good question. I don't like the SDK. Because as I also inspect the SDK, it's not really a magical inside SDK, it's just the code you are writing to read, for example, a queue, to read event grid. So in my opinion, it's better to use a plain console application which has not lock-in to the platform. Because the really important thing to keep in mind is that if you write a console application, that console application runs without any SDK, without any lock-in, without anything. When you use the web job SDK, of course, you are tied to that SDK. And the value added, in my opinion, is not so high to justify the usage of the SDK.
And last question, sorry guys.
No problem.
Regarding the continuous web jobs, right now we don't have any possibilities to see the parameters of triggered web jobs if they are started as continuous web jobs. Are you aware about any plans regarding the...
What did you mean about parameters?
Parameters, I mean when it was scheduled with which parameters and so on. I mean timer triggered web job.
Ah, okay, yeah, because they are attributes. So you bind the attributes inside the code?
Yes, yes, I know. But for the console applications, we use settings jobs.
Yeah.
But for the continuous web jobs, we don't use it. And when we have the attributes for the function to specify when and how repeat and so on, we don't have any possibility to see such settings in the on the portal.
Okay, yeah, it's quite tricky. We can go, if you have time, we can go into details after. Okay, okay, so after with the computer. Okay, no problem.
Yeah. And the last question?
Just in case you have some experience with the Service Fabric Mesh, could you please relate it to App Service? Is it the future or what the trend is?
Okay, it's quite opinionated, this question, because...
Obviously.
Yeah, because Service Fabric, the plain one, was born as the promise for the future. So no, use Service Fabric is the future and so on. Then the container battle, war, was won by Docker and Kubernetes for the orchestrator. So Service Fabric became forgot my words, useless. Because for the container technology is useless. It's very useful for the actor model if you are using the SDK. So in that terms, Service Fabric Mesh can be good if you have huge loads of application that needs to process something in memory and also have stateful application. But I don't think other really relevant situation of scenarios where you really need the mesh. You can use, for example, the durable functions, but you have some limitation of the functions. So probably to make that durable scenarios with actors and so on, web jobs are not suitable. Are not really a good choice because you have to write a lot of custom code to make things work, but probably investigate the durable function better. Okay?
Let's thanks again our speaker for this interesting lecture.
Thank you. Thank you again. I'm here out